Method of undetermined coefficients. So step 1, choose functions appearing on the non-homogeneous side. Okay. So if it was sine x, you have to put sine x into your thing that you want to create. Okay. But not only that, you want to include also include its or their derivatives. Include their derivatives. So in other words, in the equation, if we had sine x on the right side, not only you want to choose the sine x, but you also want to choose the derivative of sine x, which is cosine x. Okay? So after doing this, you will have a bunch of functions chosen, right? And then when you have a bunch of functions, then make step 2, make linear combinations. Linear combinations of the functions chosen. With undetermined coefficients. However, there could be something interesting going on if one of these, or one or some of these functions in your linear combinations also happen to be the complementary solution. So for this one, I'll show you an example and we will discuss that later. Okay, so step 3, find YC, okay, which is solution of the homogeneous equation. Homogeneous differential equation. And check for duplication. If there's a duplication, then there's something you have to do. Okay? But I'm not going to tell you now. It's going to spoil the fun, right? So, if there's a if there is duplication, then there is some additional process that you have to do, okay? Which I'm not going to tell you at this point. All right. And then, step 4, plug in the linear combination into the non-homogeneous differential equation and determine the coefficients. And then finally, step 5. Once you did everything, then your general solution is the sum of the complementary solution plus the product. So that's the general plan of the method of undetermined coefficients, and you pretty much know everything except this part, how to deal with the duplication. You have a question?
So we only do that step 4 and step 5 if there's no duplication.
Yeah, if there's no duplication, well, no, if there's a duplication, there's something extra that you do,
And
but then you come back to
5.
4 and 5. Yes. You have a question?
Does this only work with trig functions?
No, actually, that's a great question. This method of undetermined coefficients will only work with exponential functions, sine, cosine, and polynomials, and some product of them. But beyond those 4, you can't use it. So for example, if you had like e to the x squared on the right side, then tough luck, you're not going to be able to use this method. Okay? See, the real problem has to do with the first one. So for example, if your right side was simply a tangent x, it looks innocent, right? But if once you try to apply this step 1, then not only you have to include tangent x because it's the function itself, but then the derivative of tangent is secant squared. And then derivative of secant squared is something times secant squared times tangent x. So that has to be included. And then the derivatives, they never stop. So the list goes on forever, and you can't do anything. However, if you had sine x, if you differentiate sine x, you get cosine, but differentiating cosine, you come back to sine again. Although it's negative sine, it doesn't matter. It's still some multiple of sine, so in that case, we just need sine and cosine. Same thing for exponential functions. Say e to the negative x. The derivative is negative e to the negative x, but it's the same function, different coefficient. So if it's the same function, you don't add to the list. It's the same thing. Polynomials, x to the third power. You would differentiate x squared, x to the third power to get 3x squared, so you add x squared to the list. Differentiating x squared will give you 2x, so you add x to the list, and then constant, and then it goes away. So again, you just have finitely many things to add to your list. In that case, you can use this. If this list never stops, then you can't use this. So this doesn't really solve all non-homogeneous case. That's why there's one more method that you have to learn when this is not feasible. And the other method is called variation of parameters. And also, although it's much harder than this one, it will handle some more functions than what this is doing. Okay? All right, so let's see how this can be applied for the next example. Let's try that. Okay, what if we have y double prime plus 4y prime plus 5y equal to, let's just do x squared. Let me put example numbers from now on. Example 1. Let's say we want to solve this. What should your YP be? First, I see x squared on the right side. So what do you put?
X squared.
X squared. You put whatever that appears, you want to put it there. And then if you differentiate x squared, you get 2x. So you want to put the x there. Because we're going to put a and b as their coefficients, we really don't need to put the 2x. We just put x itself. Okay. Actually, even if this was 5x squared, you would just put x squared, okay? You don't care about the coefficients, because coefficients are undetermined. Okay? Now, if you differentiate x, you get 1. So what do you put? Just 1, yeah, or plus c. Okay? And if you differentiate 1, it's 0, so we don't care. Okay? And this is what we're going to put in the left side. And it will just work out. You will be able to find a, b, and c once you solve it. Okay? Y prime 2ax plus b, y double prime 2a. Plugging in everything into the left side, you get 2a plus 4 times y prime 2ax plus b plus 5 times the original one, y, which is, let's collect the terms. This is 5ax squared. That's the highest order term. For the x, you have 5b and but also 8 times a, right? So 8a plus 5b. And then 2a plus 4b plus 5c. That's the constant term. Now, what do we need each of these to become? I need the 5a to be what? 1, because I just have x squared, right? If the right side was, say, 5x squared, then I would need 5a to be 5. Okay? But here we need it to be 5, and we need it to be 1. What about this one? What should this become?
0.
0, because we don't want x term. It's not on the right side. There's no x here. What do we want? What do we want this to be?
0.
0.
If all these conditions are met, then it will satisfy the differential equation, and we would have found one particular solution. Oh, I forgot to do the step 2 or step 3, which was to solve the complementary one and compare. We have to do so before this, we should have solved and found the complementary solution. Right, so what's YC? YC is the solution to the complementary differential equation, which is nothing but deleting the right side to be 0, so that your characteristic equation will be r squared plus 4r plus 5 equal to 0. And this one is r plus 2 squared plus 2 squared gives you 4. 4 plus what gives you 5? 1. So that r plus 2 squared is negative 1. Take the square root gives you, taking the square root gives you
I.
plus or minus I, and then what r is equal to negative 2 plus minus I, which means your complementary solution is what? First, negative 2 gives you the number for the exponents, right? But then there are two things. One for cosine, A, cosine, and what goes in here? Since it's 1 times I, it should be 1 times x. So I'll just put cosine x. Oh, I shouldn't be using A because I've been using A and B for the undetermined coefficients, right? So for this one, let's use C1 and C2. So that's the complementary one. You should always find the complementary solution before plugging in the y particular into the left side. Okay, you should always do that. And then you have to check for duplication. And you can see that because these are exponential functions and cosines, there is no duplication with this and our original yp, right? So in that case, we can just safely go on and just set this one equal to 1, that's that equal to 0, that equal to 0, and we can figure it out. Okay. So let's try. First, 5a should equal to 1. That makes a equal to 1/5. Then 8a plus 5b should equal to 0. So that means b is equal to negative 8a over 5. And because a is 1/5, 1/5 times negative 8 over 5, that gives you negative 8 over 25. Then 2a plus 4b plus 5c should equal to 0, which means that c, oh, let's leave the c here. You get negative 2a minus 4b, and when you plug them in, it's negative 2 over 5, whereas plus 4 times 8 is 32 over 25. And because this is negative 10, you get 22 over 25. 22 over 25. So that's why we get 1/5, negative 8 over 25. Oh, no, we're not done yet. We have to divide by 5, right? So dividing by 5, we get c equals to 22 over 125. And plugging those numbers back in, we see that the y particular is equal to 1/5 of x squared minus 8 over 25 x plus 22 over 125. Now what's the general solution? Add these two up. That's the general solution. So yg, the general solution is e to the negative 2x, c1 cosine x plus c2 sine x, and then plus 1/5 x squared minus 8 over 25x plus 22 over 120. That's the general solution. And I don't think anybody here has the patience to plug that back into the original equation, but if you did, and you did these long and tormenting calculations, you will find that it does satisfy the different equation. So that's the solution.